Hi, I'm Paul Fardo with Agilent Technologies. I'm an application support engineer, and today I'm going to be speaking to you about a current measurement being done with a traditional current method, which is an oscilloscope and a current probe, versus an N6781 with seamless measurements. The advantages of an oscilloscope and current probe is that the bandwidth typically is pretty high, typically from DC to 50 megahertz. It also has some high current capability of up to 15 amps. The rise time is 7 nanoseconds, so to actually make current measurements which have a very fast rise time, this device is the ideal product to make that current measurement. There is an easy connection to the device. It's just a simply clamp on. So there is no need to actually cut a trace or anything like that. Just basically clamp on the current probe. The advantages of the N6781 seamless measurement: it has a resolution equivalent to 28 bits. It also has an accuracy better than 0.03%. The dynamic current measurement capability of this product is 100 nanoamps to 3 amps. It has the seamless, what we are calling a proprietary circuit auto ranges without any glitching occurring to the measurement. It has also a multiple simultaneous measurement capability, so you could measure voltage, current, and power, and get a lot of detail in that analysis from the waveform. The limitations of an oscilloscope and current probe is the DC accuracy is approximately 1%. The AC accuracy is 3 dB. The offset error of a current probe is an issue where it actually starts drifting over time, and you need to continuously degauss the actual current probe. It also has, for low signal level, it's very noisy. So trying to resolve low amplitude signals is very difficult. The low amplitude limitation of a current probe, typically the minimum is only 10 milliamps per division. Now, the limitations of the N6781 seamless measurement: it has a bandwidth limited to 30 kilohertz. And also, if you need to make current measurements higher than 3 amps, you're not going to be able to do that with this product. From a product selection standpoint today, we only have 2 models available, the N6781 and N6782, which has a seamless measurement capability. So now I'm going to be going to the actual setup and the device that I'm using to do this test. Over here you could see that I'm actually using a little weather station that actually transmits temperature and humidity to a receiver, and it transmits pulses of current periodically to the receiver. So the one thing that you note here is that I'm using the N6781 to supply the voltage to this device, which is 3 volts. But then, in order to make current measurements of this device using the traditional current measurement technique, is I had to put a coil of 5 turns in order to magnify the current level during this measurement. And as you could see here, I have my current measurement amplitude is at 5 milliamps per division. The reason I could do this is because of the 5 turns. So I add a constant in the math of the scope and gives me the capability of making this measurement. As you could see, the current measurement that we have here is in this area on the lower current level measurements. It is very noisy, and so it is extremely difficult to really resolve any information here due to the noise. And you also could see that the actual current probe has started to drift. So now below, with the N6781, at 5 milliamps per division, you could see that the signal-to-noise ratio is a lot lower. So comparing the two signals, you could definitely resolve a lot more information here. So one of the things that I'm going to be doing now is actually try to even get more detail on the oscilloscope view. So I'm going to be turning the amps per division to 2 milliamps on the scale of the scope. But that means that the noise signal ratio is now even higher. But you could see that there's something here and there's something here. But you still can't get any true accuracy due to the noise measurements. So below, I'm going to change the amplitude of the DC power analyzer. And I'm just basically turning the offset to analyze the low signal level that I want to demonstrate here that you cannot even see on the oscilloscope. So as you could see that things are happening on this device when I have my amplitude set to 100 microamps. Well, when you go to the oscilloscope, you cannot even see that here. It's just buried in noise. So the detail of information that you gain with the N6781 is pretty powerful. So in conclusion, I would like to summarize this experiment. If you need to make very low current measurements on a pulse measurement, the N6781 has a seamless capability that by far surpasses the capability of a current probe measurement using an oscilloscope. Thank you.